Okay, hopefully it's going to work. Check. This is a little weird because I'm using display capture, but today we are going to watch because I already did this but didn't have audio, my play of levels 11 to 15 from Devil's Calculator, but we're going to do this more quickly than usual, just because it's not really much has happened. Let's start with level 11. What do we have? Basically, the first idea that I had was a function f of x equals minus 5 plus x. Because I had two numbers, 0 and 1, and if you look at 0, if we assume that this is a linear function, we know our function always has the form of f of x equals m times x plus b. And if we have a f of 0, then we always know what b means, because f of 0 equals m times 0 plus b, which is just b. In this case, my assumption was minus 5 plus x. However, I noticed by inputting 10, f of 10 equals minus 45. And my assumption is that we use our function that I theorized f of x and use it on each single digit of our function f of x. Meaning, just as an example, 300 is a conjunction of three numbers. It is made up of 3, 0 and 0. And my assumption is that f of 300 is f of 3, f of 0 and f of 0. And my further assumption is that the lead number, the 3, commands wherever we have a plus or a minus in front of our numbers. So the value of our number is demonstrated by using our function f on each of the actual numbers, but then the actual orientation of the number, whether it's positive or negative, is just ordered by the lead digit. The lead digit is the dominant factor in this. So I checked in what do I need to input to make 666 or just to make 6 as an output, and the answer is nothing because that doesn't work. So I'm using minus 6. And this is the idea. Minus 666 is the output, and that's pretty easy. I just needed to find out a combination of minus so that this works. Level 12. This is a little better, I think. Now we have an interesting situation. We have this kind of function. It is 0, minus 82, minus 6, minus 80. It looks like a jumping function. But if you look more closely, you see that we have a differentiation of whether the number that we input into our function is even or odd. If the function is odd, then we have this here, x minus 83. But if it's even, then we have minus 3 times x as a function that we're using. So if we want to find out the input for 666, we first have to always differentiate between even and odd functions. I think we had that function in the last video too, but I'm not sure, because I have made this video multiple times. Because I messed up again. Anyways, so that's the idea. What do we do now? We just try to look into the pre-images of f of x equals 666. Meaning we look at each number x, which if we input it into f, equals 666. If we assume that our number that we need to input is even, then x has to solve the equation 666 equals minus 3 times x, which this upper equation here satisfies. So I'm writing here x1 even, x2 odd, and in this case, if it's odd, we need to satisfy this equation. Since we can't use all the numbers, those two numbers don't really work. We need to find other numbers. So I just need to continue this. For example, x3, which is the pre-image of 749. And just to make it a little more visual, I tried to make a little bit of a binary tree. So this binary tree has to read as following. In the first layer, we have a 666, which is our base. In this case, it is the image of f which we want to create. But we're going to talk about this as the base. The next layer, the second layer, is all the values which are pre-images of 666. And in this case, we have to make a distinction of the even values, which are pre-images of 666, which is on the left side, and the odd values of 666, which is on the right side. And we do this for those numbers too. So in the next layer we look at the pre-images of those two numbers. Sometimes the pre-images might be empty, they probably won't be empty, but they might not always be two values, but sometimes just one value. You can see this with the right number here, 749. If we look at odd and even pre-images, then if you look at this number, it is not divisible by 3. Because if you look at its the sum of its digits, 7, 4 and 9, equals 20, and that's not a number divisible by 3, so 749 isn't divisible by 3 either. So the number that we can input into this thing cannot be even. And the number that we can input that would have been odd is 832. And now you notice something, 832 is actually not an odd number. So this means that our pre-image of this number is actually empty. So this thing, 749, will never come up as a number in this calculation. I made a small mistake by thinking that it was actually possible, which is why it's now there, but it's actually not. So yeah, let's check out more. We're going to check out the pre-image of -222 with x4 is odd. Okay, x4 equals -139, and we can actually input that, so I just have to figure out how to input that on the calculator, and we have finished. Oh, and I made a mistake, as you could see. I inputted it, but I got 168, and I was confused, so I just calculated again using an actual calculator, but I just made some input error, I don't know, but actually it worked. So next round, this function, f of 2 equals 10, f of 3 equals 12, that was my stomach, and f of 4 equals 14. Okay, so it's again seems to be a linear function. It's already a good sign. And the linear function that I'm assuming it to be is 6 plus 2 times x. I'm just going to show you how to solve a linear function. I'm looking at two of the points on this graph, which is 210 and 312. And I'm using those 2 points and graphing them basically. This is just more so an image because this graph here doesn't really say anything, but you can actually graph those numbers. And I'm looking, basically I'm trying to make a triangle of those 2 and 3 numbers. So this number, this number, this number here is basically on x, on the x scale, it's on the, if we go to the right from here, it's on the same part away as this number, and if you go up, it's the same height away as this number. So we get this point out of that. And now I'm trying to calculate, if you go up and if you go right, this how do I do this? You should just go right this specific straight line. Then how many steps on this graph do you go upwards? And how do you calculate that? You check out how long each of those steps is. In this case, I'm doing that by having the vertical height of the step would be 12 minus 10, so the difference in the y direction of those 2 points. And the horizontal step would be 3 minus 2, which would be the difference in the x direction, which would be 1. So all I'm doing is dividing those two, the height difference divided by the horizontal difference, and I get an increase of 2. So the function increases constantly by 2 on its way upwards. So that's how I got the m equals 2, and all I now have to do is figure out the b. You can write it in linear equation as m times x plus b. Any linear equation can be written like that. I just figured out the m, I now have to figure out the b. I'm doing that by just inputting a point on the graph and solving the equation for b, which in this case 10 equals 4 plus b, which means b equals 6. You might not remember this, but we did all probably do this in school, so just a little refresher. Anyway, it's basically now I'm just using the function over and over on 666 again, the pre-image of that function, solving the equation, and then at some point I'm finding a number which I can input that will work. So that's it, nothing too special. And this is the last one we did on that day, which is just pretty simple. We have to write 666 in binary. How do you do that? This is the numbers of binary, and this is the power, the nth power of 2. All those numbers are the nth power of 2. We have 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024. All those numbers are powers of 2. And I'm writing which powers of 2 they are. This is the 0th power of 2, the first power of 2, second, third, fourth, fifth, and so on. And we just need to always find the highest power of 2 that fits into our number. Build the difference between those two numbers, and then do it again. Do it again until we have nothing left. So all we now have to do is write each of the numbers that we have in binary. Powers of 2 are pretty easy to write in binary. You write a 1 at the first number, and you write as many zeros as this is the power of 2. For example, if 1 is the 0th power of 2, so you write 1 as 1 and 0 zeros, so basically a single 1. 2 is the first power of 2, so you would write a single 1 and a single 0. So you just add those numbers together, and that's how you get that. Pretty simple. And that's it for this video. This was a pretty annoying video for me, because I made a lot of mistakes in kind of recording and stuff. But the next video I have done no mistakes in that regards. So have a nice day and goodbye.